Hey everyone, Courtney Linder here, Deputy Editor at Popular Mechanics. I'm in the clubhouse today with Dr. Neil deGrasse Tyson, astrophysicist and science communicator. We have a ton of questions about the universe, and who better to ask than Dr. Tyson himself. Thanks for joining us today, Neil.
I love that you call it a clubhouse. It's very social, and discoveries always happen at clubhouses.
Absolutely. I'm going to start out simple here. What got you interested in science studies, and who were your greatest influences, or what historical events made you decide to go in this direction?
And my interest began when I was 9 in a first family trip to my local planetarium in New York City. And my local planetarium in New York was the Hayden Planetarium, where I now serve as director. It was a cosmic baptism. When the lights dimmed, the stars came out, they look up in the dome, and there's more stars than I can count. And I was pretty sure it was a hoax because I knew how many stars there were in the night sky. So I counted them from my residence in the Bronx, New York. By the time I was 11, I figured it out. And I knew by then that I wanted to be an astrophysicist. You ask about influences. The code word for influences is role model, but I think the concept of role model is overrated. If I had to find someone with dark skin from the Bronx who studied astrophysics before I did, I would have never become an astrophysicist. Finding role models actually constrains your freedom of choice if you really want to sort of engage all possible world lines, all possible outcomes of your life. So what I did instead was assemble role models a la carte. So I found an educator who was in the employ of the American Museum of Natural History in New York City, where the Hayden Planetarium is located. I found an educator there who had such beautiful, humorous, engaging turns of phrase, and he knew how to tell stories that you didn't want to leave the room.
That's powerful.
So I said to myself, if I am ever an educator, I want this kind of sort of power of passion, communicating what I love to an audience. And there was a scientist there who knew everything about the universe. And I said to myself, well, if I'm ever, finish this PhD thing, I want to know as much as he does. Now, there I am, like 13, thinking to myself, I will never learn this much, ever. But I'm only 13, right? And this is like a full-grown adult who went to college and graduate school and postdoc and everything. I knew that's the kind of scientist I wanted to be. My parents were devoted their lives to helping others. They were active in the civil rights movement. And I stayed grounded the whole time. I said to myself, if I'm going to try to create within me concern for other humans in this world, I had excellent role models in my parents. So I make this sort of Frankenstein role model with bits and pieces from people who had talents that I wanted to emulate. And so that's my origin story.
I love the way you put it about the Frankenstein of role models. That's something that, hopefully kids will watch this and be able to relate to that a little bit. There's no way you could have possibly known everything about astrophysics when you're 13, right? Well, there's a part in your book, your new book. So in the book, you're talking about how in 1995, you set out to look into the doubling of all of the literature from the Astrophysical Journal. Could you tell us a little bit about that experience and how that relates to this idea of publish or perish culture that I've seen talked about a lot in the media?
So the book Starry Messenger, Cosmic Perspectives on Civilization, is what the world looks like, what society, countries, cultures, civilization, what it looks like when you're scientifically literate and when you have some kind of sort of cosmic perspective on it all. So in all turns of page, what you're doing is you're taking a step back from something that you believed you understood with great authority or great passion, and you say, no, wait a minute, you can look at it another way. So I was in a library when I was postdocing at Princeton University. They have a library there. It has on display our preeminent journal, which is the Astrophysical Journal, uncreatively named the Astrophysical Journal. This journal is so important that it's not scattered onto the shelves. One of the walls of the library has just that journal on it. At the time, every journal published from the inaugural journal in 1895 up until when I did this experiment in 1995. And I just saw this wall and I said, gee, I wonder I wonder what the doubling time of research publications is. So how would you do that? Well, you just look at the wall. The latest journal is 1995. What is the date of the journal in the exact middle of this wall? That would mean half of everything published before that equaled half of everything published after. That date was 1980.
So what does that mean?
So I said, how about everything from 1895 to 1980? Where's the midway point on the wall for that? It was 1965. And then I kept having my way back, and I got to 1925, and I realized, oh my gosh, I am living in a time where as much content is published in any 15-year period as was previously published in the entire history of the journal. So this was the doubling time of my field. Then I checked with other fields, and it's approximately the same among all active sciences. And then you can say, well, are people just publishing more? I mean, is it just publish or perish? Is it maybe it's all diluted? Is it? But then you look at it and you say, well, no, there's more collaborations. The two of us can publish twice as much as either of us can publish alone. And then you have large collaborations with particle accelerators, the Hubble telescope. I did another analysis on the spending in the sciences in the United States. The takeaway here is at any time you look at what's being discovered, it feels like you're living in a special time. But that is the exact profile of an exponential growth curve. What that means is step into that curve at any time in the past, and you will say to yourself, boy, we live in special times. By the way, you can do this for other things. This science is one thing, but how about patents? The number of millions of patents between 2010 and 2020 was greater than the number of patents between 1960 and the year 2000. Plus, there are more people, population is greater, and there are factors that contribute to this, but it doesn't change the revelation. When you have an active nation engaged in research that values the free expression of thought, with that combined effort of investment and creativity and freedom, you should not be surprised that you think you're living in special times. It's all special.
Talking about exponential concepts, it's also something that we just literally have a hard time wrapping our minds around. One of the things that I'm really curious about is inflation theory. How can we wrap our mind around these exponential concepts?
Yeah, so your mistake there is to assume that you can make sense of it. Okay, sense.
That's fair.
That very construct implies that our 5 traditional senses, honed on the plains of the Serengeti, were exquisitely tuned to not get eaten by lions and to find food, to find shelter, and to reproduce. This is what our senses are best at. You want to say, let's contemplate infinity or quantum entanglement? These things fall completely outside of our sensory experience. One of the great features of modern physics, with the introduction of Einstein's relativity in 1905, special relativity, general relativity in 1916. We are currently in the centennial decade of the discovery of quantum physics. All of this transcends common sense. The experiment guides what is true, and verified experiments, of course. And the mathematical model of what the universe is doing when it's shown to be successful, it's the objective truth of what's going on, whether or not it makes sense to you. Inflation it's basically a phase transition in the early universe. By the way, we live with phase transitions. We don't think of them that way. But just imagine you grew up on the equator, and I bring to you a vessel of water, and I say, I'm going to put it in a box, and a half hour later, I'll pull out the water, and the water will be solid. You'll say, no, how can water ever be solid? You'll just freak out if you've never seen or experienced that before. That's a phase transition, where what was going on before has little resemblance to what's going on after. Our hunches tell us phenomena in the universe can go through phase transitions. And one of these is a period of rapid expansion of the space-time continuum. So general relativity gives us our tools to understand things like black holes, curvature of space-time, the expanding universe, all of this. But it doesn't work for the very smallest of scales. It doesn't play nice in the sandbox with quantum physics, which is our description of the small. But what happened in the very early universe when the large was small? Would the quantum phenomenon affect the entire universe if the entire universe was the size of quantum phenomena? That's where all these weird, wacky expectations emerge from when you manipulate the equations of the early universe. The equations allow this naturally without having to invoke it by fiat. And so that's why it has received such attention that it has. Even though we haven't discovered one yet, we don't know how you would experimentally test it, but the theories and the math gives it to us. And so maybe in the future, there's some clever way we'll say, if we poke a hole in our universe, maybe we'll get access to this parallel universe that previously we had no idea was there. Just because you can't experimentally verify something now doesn't mean you shouldn't keep thinking about it, because later on, solutions might arise that will make that possible.
Everyone's talking about the James Webb Space Telescope. It is turning up these incredible images. So from an astrophysicist, what are some of the greatest questions that this research could answer for us?
So much had to go right to deploy this telescope. It's a telescope bigger than the fairing that launched it. Clever engineers had to figure out a way to furl the telescope so it fits in the fairing of the rocket. Then we sent it 1 million miles into space, have it deploy heat shields so that the temperature of the telescope can drop to almost near absolute zero, basically adopting the temperature of space itself, so that it can observe objects using infrared light that would otherwise be contaminated by the telescope radiating infrared light itself. All of that had to work. And so we approached it with softened expectations for the telescope. Even though the telescope only met the specs, it exceeded all of our expectations. There's a gap in our telescopic space-time continuum where nothing on Earth could get high-quality data from that early on in the universe. A little bit of astrophysics, those galaxies being born emit copious amounts of ultraviolet light. So why wouldn't we design the telescope to see ultraviolet? Because since that light's been emitted, the universe has stretched, and the light moving through the universe has its wavelengths stretched, and so it's no longer ultraviolet. In fact, by the time it reaches us, it's infrared. So that's part of the brilliance of its design. The infrared enables you to penetrate gas clouds nearby to observe stellar nurseries, the birth of stars and planets. So two edges of the universe, nearby and the early universe, are being served by this remarkable instrument. It did what Hubble did, but just in a matter of a few exposures. I mean, it's a portal through which we've been transported to a new era of high-resolution, high-quality data in modern astrophysics. I was asked, are we in special times because of this telescope? And I said, we all said that when Hubble launched, okay?
Right.
Wow, this is better than anything before. These are special times.
I think those comparison photos between Webb and Hubble are incredible and really illustrate that point. This might seem like a silly question, but whenever we see an image from James Webb, we're looking into the past, essentially. Do those stars or galaxies that are in the past still exist in the present? How do you wrap your mind around that idea?
Oh, no, it's easy. That's the easy one, okay?
Okay, I'm relieved because I'd love to know.
So if we were in the same room, we're Zooming together here, but if we were in the same room and let's say you were an arm's reach from me, I don't see you as you are. I see you as you once were 3 billionths of a second ago. Okay, light travels about 1 foot per nanosecond. Nanosecond is a billionth of a second. Well, you live 100 years, so 3 billionths of a second is not an important amount of time. I'm not saying, oh, you're holding on well. This is not what we say to people, but let's put you farther away. I'll put you on the moon. Now you're 1.5 seconds away from me. On the sun, 8 minutes away. At some other stars, right, 20 years away. So then I'd see you as you were 20 years ago. That matters to your lifetime. You're different. For most stars in our galaxy, the light travel time is small compared with their life expectancy. So we're not losing sleep over whether the star whose light we receive today is really different from whatever that star actually is doing today. We don't lose sleep over that. There is a category of stars that do blow up, and we do see those every night with specialized telescopes that are tuned to find exploding stars. These are stars that are exploding. They exploded thousands of years ago, millions of years ago. And the light from that explosion was duly headed in every direction. The little bit of it coming towards us then greeted our telescopes. We speak of them as having exploded in the present just because it's easier that way. So it is true that what we see in the night sky are all ghosts of something that may or may not still be there.
Okay, so we were talking about the multiverse. We could talk about simulation theory as like an alternate kind of way to think about this. Is there a chance that people are being controlled by either a computer simulation or some sort of advanced civilization, and that is kind of our idea of a simulation theory? Or is there more to it than that?
So I'm on the fence about that, and I'll tell you why. In Starry Messenger, almost every chapter, I bring in an alien to get a completely detached, independent comment on human behavior. For example, when we think of our intellect, right, we say humans are the smartest animals that have ever been on Earth. Well, you tell me, who decided that?
Us.
We did. Okay, thank you.
Yeah.
And so we have the audacity to go send probes out searching for other intelligent life, implying that we are some measure of intelligence, whereas we have 99% identical DNA to a chimpanzee. So you might be prone to say, especially if you're religious, you would say, well, what a difference that 1% makes. That makes all the difference. Because the chimp can stack boxes and reach a banana, whereas we have philosophy and art and music and poetry and science, and there's no comparison. Well, ask yourself this. Maybe the difference between stacking boxes and reaching a banana and the James Webb Space Telescope is as small as that 1%. If our toddlers can do what the smartest chimps can do, imagine a life form in the universe 1% beyond us. In the same way we are 1% beyond the chimp. Just imagine that. If they exist, then the smartest human would rival their toddlers. So what would they do? They'd roll like the smartest human, like Stephen Hawking, roll them forward and say to their humanologists, those who are studying humans, they say, this human is slightly smarter than the rest because he can do astrophysics calculations in his head. Like little Zardock over here, my toddler from preschool.
I love that.
Their simplest thoughts would transcend our most brilliant thinkers. Just forgetting a simulation universe. Just imagine if they came upon us. If they wanted to, they could just turn Earth into a literal aquarium terrarium, a zoo, for their own entertainment. Which, if you were in a zoo by someone as smart as I've just described, would you even know it? You've seen ant farms that kids bring home and they put it in the plastic thing. Ants are busy moving dirt around. And do they know they're in an ant farm? Maybe, but do they care? No, they're busy doing their thing. And so I cannot rule out the possibility that our intelligence is so feeble relative to that of some alien species that we'd have no idea that we were being watched, manipulated, and the like. Then I wondered, could we be some simulation? And we have those in our own culture. The sim games were very popular. I played Sim City. There you are, you're mayor and you make everything balance and you're happy. You got the school funding and Godzilla, a monster walks through the city. And I remember saying, that's not real. If I'm gonna be a real mayor, you have to have real things. No, Godzilla is real. You know what Godzilla is? Godzilla was Hurricane Sandy in 2012 that took out New York City. Godzilla is September 11th in New York City, which took out the city. There's something real about the concept and the consequences of what was portrayed in that. It could be in these smart alien worlds that, yes, we're a simulation run by some juvenile alien still living in his parents' basement, perhaps.
Oh my gosh.
It could be. I'm not going to rule that out. Then I thought to myself, what might be the best evidence that we're just being completely manipulated? Well, okay, what was it? So we have a country getting along just fine. This is the aliens talking to themselves. Things are getting boring. Let's make a real estate billionaire president of the most powerful country in the world. Boom, in comes Trump. Okay, now they have 4 years of entertainment. That's not enough. Let's put a pandemic in. We haven't had one in 100 years. So part of me, that's why I'm on the fence about this. Part of me is thinking, every time we're just emerging from something calm and tranquil, they got to stir the pot somehow.
Yep, feels that way. Tying together the Fermi paradox into this, there's this idea that we should have found aliens by now, right? But what if the aliens are controlling a simulation that we just live in?
Fermi paradox is, why haven't they visited us? It was a thought experiment put forth by the Italian-American physicist Enrico Fermi back at mid-century, mid-20th century. And the way it works is, once you are intelligent in your tree of life, and let's say you figure out how to travel among the stars. Let's say you don't reach the speed of light. How about just 10% the speed of light? Well, at 10% the speed of light, you can cross the galaxy in 1,000,000 years. 1,000,000 is small compared to the time life has been on Earth, okay? And that's the full width of the galaxy. In between, it would take 10,000 years, 50,000 years, 20,000 years. The comment is, you could colonize a planet, and then it colonizes 2 planets, and each of those colonizes 2 more planets. It goes from 1 to 2 to 4 to 8 to 16, and it spreads rapidly once this kicks in, populating the galaxy on a relatively short period of time. If that's the case, how come they haven't visited us? That's the Fermi paradox. I just have a couple of solutions to it. Either just space travel is really, really hard, even if you're really, really smart. That's one. Maybe they have visited us, took one look, and phoned home and said there's no sign of intelligent life on Earth, and then rapidly flew back to their home planet. This one is a little more intriguing to me. The possibility that whatever is the urge to multiply colonize planets, I send you out there and you've got this go-getter attitude, and I'm going to explore and I'm going to colonize. So you colonize this planet and that one, and throw in 2 more. But wait a minute, the people doing this have your exact same attitude. And so they want to discover planets. And what happens is you reach a point where people want to discover each other's planets, but others are already there. What does that create? Conflict. Wait, where have we seen that before? Oh, we had Portugal and Spain and France and England and the Netherlands all colonizing the world because they believed the world was theirs, even though people were living in the places they went to. All right, fine. So England comes to the New World. Wait, Spain comes to the New World too? So does the Netherlands. And fights begin. New York City's original name was New Amsterdam. Though the Dutch were there. Oh, then the British won it. Okay, then it became New York. The contest of land, real estate, that we've seen play out on Earth, in principle could play out among aliens. And when that happens, the entire system implodes, because they cannot get along with each other. And for me, that's a more intriguing outcome of a species that totally wants to colonize an entire galaxy worth of planets.
I'm learning that no matter what we talk about, it's always going to come back to the fact that humans truly think that they are the most special beings.
Yeah, we think the universe revolves around us. Correct. The chapter Body and Mind, I talk about hoops we jump through to try to distinguish ourselves in the tree of life. We have an Olympics and we watch our greatest athletes jump faster, higher, stronger. By the way, if you opened the Olympics to all animal species, we wouldn't win a thing. We don't jump the highest. We don't run the fastest. So then there's the thing, well, we have a brain that's huge. Well, it's not the biggest brain. There are 3 brains in the world bigger than ours. It's the whale, the elephant, and the dolphin. Oh, wait. Relative to our body weight, we have the biggest. See where we're going here?
Bunch of caveats. Yeah, keep adding them in so it's convenient for you. Yep.
See how this is going. Okay. Well, for that, we're at the top. So now we feel good about ourselves, but look a little closer. Yeah, we're at the top, but not by much. You know who comes very close to us? Mice. Mice have about the same brain weight to body weight ratio as humans do. So that's a little uncomfortable. You don't want mice to be like as smart as we are. That contest that we just barely win, that only applies to mammals. Do you realize mid-sized birds have a higher brain to body weight ratio than humans do? But they're not mammals. Okay, so talking about magpies and hawks, birds that are sort of mid-sized, many of them are predators, they have a bigger brain to body weight ratio than we do. There's a video on YouTube of a magpie encountering a water bottle. It goes in, sticks its beak through the hole, and drinks the water until the water level drops below the beak. It looks around, finds a pebble small enough to fit through the hole. It drops it in the hole, displaces the water, raising its level, and it drinks some more. And it does this 8 times.
This bird is conducting its own science experiment.
Its own science experiment. And every time you want to claim that no other animals have intelligence or they're nothing compared to us, you see things like this, it makes you take pause. The animal that has the biggest brain to body weight ratio is neither avian nor mammal. It's some species of ants. There's some species of ant where their brain is 15% their body weight. 15%. For us, it's like 2.5%. So I hypothesize if aliens really care about brains, they would first try to talk to the ants. These are visiting aliens. The whales, the elephants, dolphins, then perhaps the mice. And then maybe humans, 6th on that list.
We're lucky if we make the short list, yeah.
I know, exactly. We hope we make the short list, but I wouldn't guarantee it.
From where you stand, what do you think the most important scientific discovery has been so far just this year?
It has to be the first round of data from the James Webb Space Telescope. So it didn't discover something we knew nothing about, but it provided a quality image on a level where we can now know that phenomenon even deeper. The image of galaxies showed galaxies in the early universe warped by the curved fabric of space-time in the vicinity of a supermassive cluster of galaxies in the midground. All of this is going on in that one image. Every smudge you see is an entire galaxy. That kind of full force acquisition of data that can keep astrophysicists busy for decades. And one of them was a spectrum of the water molecule in an exoplanet orbiting another star. When the planet orbits in front of the star, light from the star passes through the atmosphere and is tagged by the chemicals in that atmosphere. And they found the existence of the water molecule in the atmosphere of one of these exoplanets. And so that's a whole industry ready to bust wide open.
So where do we go next with that information?
The telescopes aren't powerful enough to see the surfaces of exoplanets. You do the next best thing and say, by the way, oxygen on Earth exists only because we have plant life. That's the only reason why we have oxygen. I remembered watching early episodes of Star Trek where they're looking around for planets that can support life. And so they find a planet with oxygen. And they say, Captain, it's oxygen, nitrogen, atmosphere. And they go down. And that's why they never wear spacesuits in Star Trek. They find the planet that's just like Earth. But they didn't know at the time that you're not just randomly finding atmospheric composition that happens to accommodate life. Life made that atmospheric composition. By looking in the atmosphere of exoplanets, the atmosphere is tagged by the chemistry of what's going on. We have a list of molecules are more likely to be there for having been created by life. That busts open that entire cottage industry of the search for life in the universe.
I bet SETI will be excited about that.
Oh, yeah. Well, SETI would jump in if by doing this, we find out that there's global warming and soot and other pollutants in the atmosphere. And that'll be a sure sign of the absence of intelligent life, I guess. I don't know. Yeah, maybe SETI would not be interested in that.
Oh, maybe not. All right, Neil, that's all I have for you. Thank you so much for your time today. It's been so much fun chatting with you and learning from you.
And keep it going. You guys are a fixture on the landscape of geeky people.